Okay, so I'm going to make a brief presentation of Travo again. Well, I will make it as a demo, and then feel free to interrupt at any point. It's not meant to be super structured. So first, as a brief description, so what Travo is about using GitLab as a mean for the exchange between students and teachers when you want to release an assignment, so send an assignment to the students, and reciprocally when you want to be able to easily collect these assignments. And yeah, we have tried a couple of things and degraded a certain number of tools, and eventually it felt to us that the natural tool to use that doing this is essentially some form of collaboration of code on code, and then it would be natural to use general tooling for collaboration of code, which would be a fork. And it turns out that our university, we have a GitLab instance, so it was quite natural to shoot for this target. Also because this meant that many people are using GitHub, but then telling my students to send their personal data on GitHub could have been problematic. So it was a target. The general principle is just following standard practice that you want, if you want to have, if you have code in a repository and you want someone else to work on it, this other person will typically do a fork, work on the fork, and possibly send it back. So here the principle is the same. An assignment is just a Git repository somewhere on GitLab with no specific constraint on it. And then when students will want to work on it, first they can just clone, and they can just access the assignment, play with it. And then there's the question is, how do we give it back? And we follow the practice that is to create a fork for the students so they will all ease version of the assignment. And the fork relation is nice because it models the fact that there is a relation between the original assignment and the student assignment, which already gives directly, as a teacher, if I want to see all the assignments of my students, I just list the forks and go there when I can. That being said, being able to use this for students means, if we just put it this way, students need to know about Git and need to know about GitLab, need to know what is a clone, what is a fork, and so on. So for our first year student, this was not quite enriched. And even for later students, doing it right so that it's easy for the teacher to recover all the information. So making sure that all students do it exactly the same way so that you can automate and find things and so on might not be that trivial. And also just making sure that first, when a student makes a fork, it actually makes a public fork that you can, well, a fork that you can actually look at. So it's good to enforce on convention, and so for both use cases, use case of it's complicated and hard to do, or yeah, students could do it, but getting them to do it in a consistent way. Automation was getting important. So what Travo is about is just about automating interaction with Git and GitLab, so that to simplify as much as possible the workflow and to make it systematic. So let's just do it. So yeah, just for information, and if you want, you can install it right away and play with it along the line. So Travo, we work on Travo with colleagues from UCAN, and so there is this. It's hosted on this GitLab repository. It's not yet published in pip, but it should be eventually. Maybe it should be now. But to install Travo is just a standard pip install. Yeah. So just install pip with pip from this, from out there. Caveat, you need Python 3, but nowadays it's becoming standard, although in the basic Ubuntu that's not always the case. Another caveat, which I just realized 3 days ago is that when we wrote it for our students, in interaction with students, and some of the messages are in French because we wanted to target all freshman students. So all the commands that you need to type on Strava are in English. But if you want to understand what's going on, and if you want to understand the raw messages, there are some cases where it's so it could actually be a good occasion to move to the next step to do something more international, or at least do it in English. Okay, having good message is one of the three parts. Now, in practice, an assignment is just any repository by default. So, do you have a preferred repository? Preferably a small one on dl.mathhub.info. Otherwise, just take one of those. But it's not fun because I'm in the members of the project.
Yeah, let's see. Yes, if you go to Slack, go to Miko MH. No, actually, Miko.
Okay.
Course. I don't know. Yeah, Miko courses maybe. Miko. Now I can't.
Which ones do you want to pick?
EVGS that has notebooks that are actually. I think we have in Miko problems.
This one?
No, not Miko MH, but Miko problems. This is the course.
That one might not be public.
Yes, I could give him that. Well,
Yeah.
probably not.
Does it need to have Jupyter notebooks? No, right? Yeah, you can just go to.
Yeah, just make anything. I don't.
Yeah.
Maybe /hello world. There is a couple in there.
That's actually a good idea. Instead of Miko MH, just use hello world.
Yeah.
Without the space for.
But it's making the search in this group. I want.
Oh, in group. Yeah. Okay.
How to make search and. Okay, alignments.
There's the Hello World group at least.
Yeah,
and in there, any repository will do.
Okay, very good. So there's Git repo, and I just get address, for example, HTTP address, something like anything. And so Travo is a Python library with a command line interface. So you have this script here, and there's this command fetch. So far it's basically doing a clone. So there's nothing major there. But there is a reason for not using clone directly. Now I've got repository. I could do anything I want. Let's say edit the README, put some crap, and right. And so now I want to I'm done with my work. I want to submit it. I do Travo submit. Now I don't need to specify the URL because URL is known. I just give the name of the directory, submission. And now it starts to be a bit more interesting because it will create a fork of the project for me, and it would run a commit, and then it's going to push this. There we are, and it tells me, oh, this is created for you in your repository. And what can we see here? We can see that this is a fork of the Hello World. So whoever has access to this repository can see, oh, there's a fork here. So you can go to the list of forks and have all submissions from your student there. You can see that it's private.
Yes.
And if we go to the project information and look at who are the members, well, everyone who had access, all the members of the original assignments had access to my fork. So usually on the original assignments, you have as members everybody that is on the teaching team and that should have access to the student version.
We should throw out Mina and Christian.
Right. So this is basic use. This is for courses where you have one assignment, you want to make it easy to collect. Now, you may want to go further for, so what kind of features do you want to have? First thing is, typically in our cases, we don't have one assignment, but we'll have a sequence of assignments. Typically, there will be one assignment per week or something like this. The reason of not making one assignment for the whole course is that typically, by giving it in small chunks, it makes it easier while you steer the course to actually adapt the later assignments depending on how things are doing. Whereas if once students have given an assignment, you can actually do little adjustments, but there is always a risk of a conflict. And so this is more like, oh, I found a typo and I will fix this typo, but nothing.
But the students shouldn't actually edit the assignment itself, right?
The original assignment, yes, but they don't have access to it. We don't have right access to it.
Yeah. But
No, but the conflict is if you do a change and if I've done a change, right. There's one dependence which I didn't write as semantic. So I didn't tell you why fetch and not clone. So the reason is that fetch you can do it several times. And the first time we'll do a clone, following time is going to do a pull. So typically this can be useful if a student is working in the computer lab at home and maybe different place. You just have to do pull, fetch, submit, fetch, submit, fetch, submit, fetch. And this will move the material from one place to the other. So no more having to send this project by email or on USB key or creative way a student have found to move things around. So this simplifies this pull and push, but there's also it will also actually not only fetch from their repository, but it will also try to fetch from the original repository. So that if you update your assignment, it will try to merge it. And if it fails, then it will fail and restore the thing in the original thing. So your student won't benefit from the new assignment, but will have a clean, like it's not going to break the thing. And if it can merge, it will merge. And you have one little thing, you can have a master branch and you can have an errata branch where you store what's really important, what's more in errata if it's not there. So this is mainly the reason for having these two commands. Actually, that could almost be only a single command, which could be sync, which would do a fetch and a push, and which would work. We haven't been all that work.
yeah, I think that would probably be a good idea.
Just to make sure that they always pull or before submitting.
I wish Git had that. I wish Git had that.
Oh,
You can make that.
You
very
make it
easy
on
with
top of
one
it.
line.
Yeah, you can make everything in Git.
So yeah.
Just get the answer by a Git user.
So one of the good news I learned by playing with this is that automating the interaction with GitLab is actually fun.
Yeah.
There's not too much pain involved, and the API is relatively well. And we have and there are we developed our own little library to interact with GitLab, and we should merge. Another one has been developed, which is more mature. We should switch to something. All right. So for more advanced features, usually for your course, you will want to have several assignments, and for the student to each time have to specify fetch and then give this long URL to get the address is a bit of pain. And also, so that's one feature that you may want to have. Another feature that you might want to have is to keep assignments from one year to the other. Well, to have the assignments from last year, and then the assignment of this year, and then the assignment of the following year, and to be distinct things so that you don't mess up with each other. And the last feature that you might want to have is to have student groups, because you have typically the way teaching is organized in France, students are in groups. Each group has its own instructor, And so, of course, the instructor want to see what are the assignments of students in my group and not the 300 assignments that are out there. So, yeah, I guess the way I'm going to show you how it works for one of the classes. Yeah, let's do the whole thing. So what we would ask our students in the beginning is to do a clone. So there will be an assignment, well, a Git repository, which will be will contain the course description in some sense. And that's the first thing that will need that the student will clone. So the case is so the student will receive as instruction at the beginning of the course to do git clone. I could fix failed. Why is it bringing me this extra crap? I don't know. Okay. And actually, the command that will give them is more to do the git clone and to name it after the course. So let's say that will be the name of the course. So what is in there? Well, basically, there can be a README, some documentation, things like this. We have put a binder directory which actually contains everything that is needed should they want to install the software on the machine. So we can do a combine install from there or things like this. So that will be the case where we actually have to install the software. And otherwise, the main piece of information is this, of course, this URL. Yeah, okay. This example is a bit particular. Let me take another one. This one will be good. Right. Okay. And so what would there be? Just a bit bigger. What will be in there essentially or import Travo, and then some metadata about the course. So it's hosted on this GitLab repository. The root group is this one, and then assignments will be stored in there. And you can see that there is a year. So for each year we'll make a subgroup which will contain all the assignments for this group. And also, in this case, there is no student group, so that will be easy. And additional feature, you can set things like expiry time, which will mean that as the repository will stay there, so the student always will have access, as long as he has access to the 40, will keep access to the repository, but instructors will only have access until a given time, and then I won't have, which is kind of compatible with how we are supposed to access data. We should be able, for exams and things like this, we should be able at any point to access the data until a given date, and then after this date, we should go, and then we will lose the fork. Actually, lose the fork correlation. No, the fork correlation will be there, but the data will be private. So as the structure will be able to access. And you can also, this is will continuous integration be set up for this. So you do this. A bit of configuration, and then when you want to actually get to fetch, you don't have to put the full URL. You will just put the name of the repository, and in this case, the name of assignments. What are the name of the assignments? One dash structure. Yeah, okay. So the instruction will be to fetch one dash. Nope. the name is structure with S on both. Structure, yeah. So which makes it's like easier, and then you can. And all right. So what are the small differences? First thing is because there is a name of a course, and because quite often the assignments for our courses are week 1, week 2, week 3, week 4. If you would have several courses, so and if you just use the standard thing, when you do a fork, by default, the repository that you get has the same name as the original repository. So you would get in your home directory in GitLab, week 1 is this week 1 about this course, week 1 about this course. So you get this little prefix there. Then for the rest, it's still a fork of this original class. So now let's look at what the organization of the course looks like.
Are you using subgroups there?
Yes.
Okay, cool. So that the forks are also organized as subgroups in the.
Not in the student repository, because the student repository is a namespace and then a group, and you cannot have subgroup in your home space.
Cannot.
No. It's annoying.
Oh, okay.
Which is silly. Which it's really easy. I don't see why, but yeah, we have a distinct notion of namespace, which is for the home directory,
Yes, okay.
home thing, and of a group, and namespace are not. That's annoying.
Okay.
That's annoying.
I didn't know that.
Yeah.
Yeah.
So this means for our students that have currently in first year, they have 4 classes, each with 10 assignments. It's just luckily it's sorted by name, so it's not too bad, but it's
okay.
So from the instructor perspective, what we usually would do, we have a group for the course in general. In this group, we will have one subgroup for each year. And this subgroup would do 2 things. First thing, it serves as a folder of all the assignments for this of the versions of this assignment for this given year. So you can still access assignments that you gave 1 year ago, 2 years ago, so on. It will also, you can also use it to model your teaching team, the instructor. So as a group, it's also a group of people. And so it models what is your team this year, which means that the teachers from this year will get access to the assignments of the students this year, but not to the assignments of the year after, which is a nice feature. And what would you have as well? So you will have this computer lab repository. So this is really about the metadata about the course, and then information on how what software you should install. Everything you need to be able to work on the course itself. And then I typically have an instructional repository. So this one will contain all the course material from the instructor perspective. Remember from the talk the other day, I mentioned the thing that usually you have an instructor version of the material with solutions, and you have the student version without solutions. So the assignment repository contains the student's version, and then the instructor's repository contains actually all the course material for all assignments, and maybe more. And there is always a question of whether this should be public or this should be private. On one hand, I want it to be private so that students don't find a solution, and I want it to be public because I want to share my course material with as many teachers as well. So, okay. Essentially, I tend to make them public and just cross my fingers that students are not going to find solutions, or that they would be too lazy to actually grab solutions one piece at a time and copy paste. You do this. The point is you do whatever you want. Travo is agnostic about this. This is just how you wish to organize yourself. It turns out that the student version is built automatically from from an instructor version, but again, Travo is agnostic about this. It's just I have a makefile that tells how to build the student version. And typically, I also have a private repository. And again, this is independent of Travo, but this we use for exams. So
Yeah.
I really wanted it to be private. And we also use it for communication inside the team. So actually, we don't exchange emails. We do all the communication through GitLab as GitLab issues, which allow to categorize, prioritize, assign, and all online features, and keep a record of all the communication throughout the year, so that new instructor can actually see, oh, what happened last year for this assignment, what were the comments, what went wrong, what went correctly. But again, this is using GitLab for teaching. This is not Travo. I believe, yeah, there's just a single feature that remains I want to show you, which is for larger courses where you have several groups. And so for this one, I'm going to take, let's say, this guy here. The same layout, you have this, well, it's not called instructors, but this is an instructor material. This is private communication, description of the course, and then things for different years. Oh, we are using GitLab since 2018. That's good. Now, the only new thing is I want to be able to model the information that this student belongs to this group, so that the instructor can find the information. I want to model this somehow in GitLab to be able to retrieve the information, knowing that I didn't want to go all the way to have GitLab to be aware, to be in interaction with our learning system and being able to find groups from there, because it's always a pain to set up these kind of connections. So the way I model this is for each of the assignments, let's say, yeah, 7-10, so 10th week, that will be the main assignment repository. But then there will be also these groups. So these are the student groups. So my group is MI3. And in the subgroup MI3, I've got a fork of each of the assignments.
Okay.
And then instead of student doing a fork of the original assignment, they do a fork of the fork. So it's kind of silly in the sense that this fork is actually really the same assignment. It's only to have this fork relation being embedded, it's there. And which means also you want to keep them in sync, so that to make sure that all of these are in sync. But then if I want to check, if I want to get the forks, I just click there and I only get the student assignments for all my students.
Yeah.
So yeah, so pretty basic way of encoding the information in GitLab. And once the information in GitLab, then I can use it to automate whatever I want to do. So somehow, in all of this, I'm using GitLab as a database. On one hand, database, and on the other hand, a place where I can easily configure permissions and right. Yeah, so only missing bit, I guess, then is you would say, oh, if I need to create all those forks by hand, and if I need to make sure that all forks are consistent with each other, it's going to be a pain. So this bit is automated. So the way to create a student assignment, yeah, let's do it for. How would I create a student assignment? So typically I would put all my assignments there. So let's say I want to make the assignment for week 1. And I'm going to put some material in my source files. Draw. So what I'm going to do, I'm going to create locally my assignment as a Git repo in whatever way. It can be automated, whatever. Something brings me material there. And then I create a Git repo, a dot some operation of the course material, and then when I want to release it, there's a command which is I need to access the course, and I'm going to say I want to release the current Git repository, so I want to publish it, and out there, let's say it's going to be called week 1, and also in the first step, I don't want my student to be able to access it, maybe because I want the instructor to check that everything is correct, but not student having an early version and then have conflicts problem, so I release it private. Yeah, this one was boring. It's boring because there is just a single group, so it's not really the so actually, I'm going to do it this way, and I should take another name. So for some of the courses, I actually have aliases, which is called the course group, and I'm going to. And then it's going to create the repo, create all the forks, create the subgroups if etc. And update them. And if they're already there, they're just going to be updated so that they're always.
The thing I didn't really understand yet is how you create the initial student groups. They're just there's
just
subgroups
just
with initial membership. Is that correct?
Yeah, or not even. So membership will be, so students don't have specific membership. So they are really just subgroups of wherever my assignments are.
So GitLab doesn't actually know who's in the groups.
No,
and just
it's
you're
purely
talking about just says I have 10 groups,
yeah.
and okay.
So it's purely the fork relationship that. So actually, a student could be seen as being in a group for an assignment and seen as being another group on another assignment, which can be a good thing.
Yeah, I think that's a good thing. Yes.
And you can change the fork relation. So yeah, I don't tell you at which point I enter the group information. It's when I do a submit, when someone would do, I won't run it because I would need to be in a submission. When you submit, you tell to which assignment you are submitting, and then you say in which group you are.
Okay.
And
which also means you can only ever submit to one group,
yes.
because otherwise your forking would have like
exactly
name conflicts. Yeah.
Yeah. And if you change group, well, if you
change groups, you probably do it between weeks, so that's fine. Right?
Yeah, but even it's just a fork correlation will be updated. Something that happens quite often is the student submits the wrong group by accident, and we just have to resubmit the correct group, and then the fork correlation is set to the right thing. So you can decide as a teacher, you can decide if a student change group in the middle of the year, you may decide, oh, in this use case, I prefer that he resubmits all these things in group of the final instructor, so the final instructor sees all of them, or because he will grade all of them as a series, or grading will be done in different. So it's agnostic. Right?
And GitLab has no problems with thousands of little
Repositories.
forks.
So far, it does not complain. You as a user might. There is some abuse here. So for example, if I go to my own home page here, my projects, I've got 1,000 plus.
Yeah, that's fine.
Well, it just means that the page listing all the projects I have access to is ruined and useless.
Yeah, absolutely. Yes, yeah.
But so
same for me.
Yeah, but I can go to my personal projects. Those are really I'm owner for, and it's more reasonable.
Still 1,000 plus.
So it's listing all of them, but this is my personal project, and there are, how many do it say?
Yeah. Okay.
Just for 40 of them, maybe, or something like that.
Yeah, you could also have another user that does the teaching.
Yeah. It depends how much control you have over the infrastructure.
Yeah, absolutely. Yeah.
In my case, I don't have control, so I have a single account. So the problem that we had with GitLab, the first thing we had issues with was we had an old version of GitLab, and so some things in the API were not there, and
Yeah.
but now with more recent, so that's fine. One thing that we add, but this was more for due to continuous integration in on GitLab setting. The runners for the continuous integration were on the same host as the GitLab machine itself. So when you would have students submitted at the same time, it would trigger all the continuous integration, and the server itself would start to be slow.
Yeah.
Whereas we don't quite care if the automatic grading is not done instantly and takes maybe 2 hours to just eat up all the jobs that have been submitted. But submission itself should be fast because the students are at the bus to take.
Yeah.
Or I actually had students say, I want to go to the loo, but I cannot. Because and then we had, of course, this means this space usage that you have to be careful with. With the original GitLab, this was several times an issue, and we had to ask to increase the space. Now it's okay because we have more space, but we do take some care to make sure that the assignments, that the repository stays small.
Yeah.
Both in terms of data of initial version and what we produce out of it. So for example, having notebooks in Markdown that don't store the outputs is a really nice thing, because otherwise this can take quite some space. And then there is always the question is what do you do with assignments, like any data science assignments where you actually have data that you want to work with. And so what we do is we consider the data as being assets very much like the software, and we don't distribute software inside the assignment, but rather in this computer lab thing that we showed earlier, this is where the data. So you would make sure that the data is installed on the machine, on the computer, in the computer lab. Okay. The use case I had were pretty much Python each time, and when you have Python module, you can assign a data repository in there, so you can use this standard setup, configure package installation because you can install the data, but it is working relatively.
Right. So students need to be okay with using the command line.
Yeah. So we need.
So Windows style pointy clicky is not supported.
It's not yet. They have something I can show you where it will be in a working condition. So yeah, at this stage, what they need to know how to do is open a terminal and copy paste the command. And the very first lab session that they have, we're spending 5 minutes to do this. But usually because the hard is clicking new terminal, run terminal there and copy paste this there, and they don't quite understand what this is. But the kind of crowd that we have, this has not been an issue so far.
Do they need to have Git installed, or does the Python stuff use a Git library?
Yeah, they need Git installed and they need Travo installed.
Yeah, okay.
Do they need their SSH keys set up and stuff?
No, oh yeah, we don't speak about authentication. So authentication goes through. So the first time, first thing, and that's one step. We need, in our current setup, the student need to log in once on GitLab so that actually they have access to GitLab. So usually, log into GitLab. Then, second step is open a terminal. So the first time you're going with Travo to interact with the forge, is going to ask for your login and password. And then it will actually request a token and store a token locally. So that next time, when any offer will come on, as you see, I do type in or passwords.
So it uses SSH internally and sets up the
not
the
SSH tokens, authentication tokens, and then everything is by HTTPS.
Okay.
So this means we don't have to worry about creating a SSH key, uploading the SSH key, which is nice. And if it was on GitHub, HTTPS authentication is now forbidden. So if there was an equivalent of Travo for GitHub, which would be interesting, this would be resolved by tokens. One thing I don't know how. So if GitLab authenticate, so it turns out that the authentication on our GitLab is by login password. It actually use SSO behind the scene, but it's really GitLab handling completely the connection process. You provide login password to GitLab and you handle something. I haven't tried it in a setup where to log in to GitLab, you have actually to go to SSO and then select, oh, from which institution am I? So when you have one of those complicated workflows to authenticate yourself, I don't know exactly what would happen there. Somehow you need to get a token. Once you have a token, everything is fine. Somehow you need to get a token. But this might be for MathHub. So that's why I wanted to try.
Yeah.
MathHub first. And then all the rest we do is essentially independent of Travo, is just setting up continuous integration. No. In Travo, so in principle, it should be just about exchange of assignments. We actually abuse it a bit by throwing stuff which are specific to Jupyter that you don't have to use, that are specific to Jupyter, so some additional functionalities that you can access for Jupyter. How to validate, how to.
Yeah, I wonder. I did this for my AI course where we have, how many people were submitting, William, this
We
semester?
had 300 people and they during the exam, 500 in the course. They submitted in groups of 3 to 4.
Yeah, so 100 person submitting at the same time has not been a problem. You could get a bit slow, but worst case, in 1 minute it will be submitted. So 1 minute is still manageable.
Yeah.
Now the submission load, I guess it's manageable. The admin load, setting things up and handling a problem.
But you would only need three or four groups for 3 or 4 PAs.
Sorry, what? Groups for TAs? What do you mean?
Setting up these groups, we've seen there wouldn't be so many groups, right? Because we don't have TAs.
I didn't understand the groups.
Okay.
I'm not sure if do you support TAs or honestly.
Yeah, that was exactly the groups that he talked about.
Yeah. So far we are. So you have this yearly group, and at this stage is the only thing that we are using. We're putting all the instructors for a given year in this group. So this means that every instructor has access to all the students from this year, which you might want or not. But you could also use a student group.
Yeah.
Yeah, it's not implemented yet. But you could also have finer grain thing where instead of putting all your instructors in this yearly group, you could put it in the given group, in their group, so that you would only have access to their own group.
Yeah.
Would be possible.
So when I'm in setup, I was more worried about what the students have to do to set that up. What
Nothing.
they have to do to explain it to the students.
No, they don't need anything.
Yeah, but
They just do this course.py,
Travo.
course.py fetch
Yeah, I mean,
name of
So
the,
we have students who
are they working on their own machine, or are they working on a Jupyter Hub or whatever?
the AI lecture. They're not using Jupyter Hub, and
They're working their own, using their own machines.
yes,
the program.
So anyway, they need to install a bunch of software for your AI.
yeah, no,
Currently nothing. They
Okay.
upload PDFs or code files. And
But could find which. Python?
product.
So we need to
Yeah.
install product.
Well, they use it in the web, and
Yeah.
then they copy paste
Okay.
into the upload file. I mean, they could install their own product IDEs, but we don't know if they do. In AI2, we can experiment with different languages, sometimes some Python. But we haven't had that many programming homeworks.
Yeah.
in
I think we should probably eventually have some.
AI2. So have some homeworks on my theory homeworks where they upload PDFs.
Yeah, and I think that the two main applications I see for this in our group would be EVGS, where we have a Jupyter-based setting anyway, and I would like to hear more about kind of the Jupyter-based thing here. It's a pity that Frederick seems to be ill, but he can look at the recording, and Jonas is not here, but he can look at the recording and talk to you this afternoon. The other thing is actually the AI systems project, where we have 50 students working in groups of 2 and submitting.
Not that many submissions, yeah. And
Yeah.
it's more a higher investment course.
Right, it's a much higher investment course, and it's really Travo will work very nicely for that, and that is almost entirely Python based.
Yeah,
in
so
practice.
I think that would be very good.
Yeah.
So I still remember the course evaluation that we got from AI,
Mhm.
where students hated that we didn't use the same software as every other course. Like just for discussions in our own forum.
Yeah, but we changed that,
Yeah,
and we'll change it even further to further integrate it with Studon.
so if we use our own submission infrastructure that people have to install,
I'm not sure for the AI course, this
Yeah.
is the best way we can do it.
that's what I would be worried about.
Yeah, because it's mostly PDF based in the grading. Right, the submission is mostly PDF, and Studon can handle that.
We could, of course, think about splitting it into, you know, upload PDFs for the theory and automatically grade it for programming assignments.
Yeah.
Especially for AI2, where we always allow TAs.
I think we'll get experience with the
Yeah.
whole thing in EVGS and AI
For
systems.
sure, we would test it with one of the smaller courses.
Yeah,
The systems project is good, but keeping it.
and even for LBS and KMT. I mean, there we already use GitLab as for submission.
Yeah, that could probably overkill, but to be honest, we have so few students. We had more students, it would be good.
Yeah, but
Like, what?
it's easy. It makes it easier for the students actually.
Well,
And more systematic. So,
Yeah, so this is just an experiment that proved that it would be easy to do. It's fairly easy to do these all user interface within Jupyter. So here in just this line, you get an user interface where you just have to choose whatever group you're in and click on fetch and click on submit. And so the thing that we're exploring is, so I haven't gone very far from on the student side. I've got a colleague that is working on similar dashboards for the instructor. So that the instructor can get an overview of how many people submitted and and all this.
But having this, so given that in EVGS, we are actually using only notebooks for for homeworks, just having a widget in the last line or something like this would be really nice.
Yeah, and
And at least in the first semester, they wouldn't even know that they're using Git and so on.
Yeah.
And when I actually get to the Git part, I can even tell them, well, this is what's behind the scenes.
one thing that goes well with it, which is that so if you have a Jupyter Hub, you can set things up so that if you put you can craft URLs so that when the student follow this URL, they get logged into Jupyter Hub, automatically clone a repository, typically the computer lab repository, and launch a notebook. So this actually notebook could be launched immediately. So just follow a link and they are brought directly to this notebook. In principle, it should be even possible to hide the code and start. They don't have to execute.
Yeah.
So we could have, I haven't experimented with something I would want to go. You could have in principle just a one click brings you to the user interface to fetch and submit, and then it's complete. Things are complete.
Nice. That would be really nice.
But at the same time, the main reason why I didn't bother is that given that I can use, well, either working on or Hub or on Computer Lab where everything is already installed, the only overhead is learn to click new, open terminal, and copy paste this, and that's fine. But, I mean, we waste 10 minutes, maybe 20 minutes average overall. So if it would be for a one-time short course, that would be a pain. But for something that anyway is going to last for a semester, and anyway we're going to use the same infrastructure and 5 of our courses, we can. It was not enough of a pain that I would develop this for.
Yeah, okay.
Very privileged. Where it's slightly, one caveat is if the students are not always working from the same place, but kind of once work on Hub and once work on their local thing, they tend to be sloppy about making sure that they always submit.
Oh yeah.
So they tend to have divergent versions, and there's a risk of conflict.
Yeah.
And of course, in those cases, they don't quite know. Well, of course, they don't know how to resolve the Git conflict.
Yeah.
That we can expect. So the approach that we have taken is when you fetch, if there is a risk of conflict, it will tell you I refuse to do the merge and leave you into intermediate state.
Yeah.
And they will propose to ask to force a fetch, which will rename the current version, local version, to the same thing with a timestamp on the directory. So your assignment was week 2, it's going to go to week 2 from this date, and then fetch the new version. And now we have 2 repositories, we have 2 directories, and they can move data from one place to the other using whatever token which to have, and that's familiar with this, and then do a submission. So it's completely manual.
Yeah, but that's exactly the right thing to do, I think. Yeah.
That being said, it's very rare that they manage to handle it by themselves. Usually it takes an instructor to
Yeah, sure.
to tell you should use a force thing and you should do this. Partly it's a question of having good error messages, which is not yet the case, telling them, okay, there is what you should do, or you should read this document on the web to learn more about how to resolve it. Most of the time, it ends up with, I get an email and tell them, read this documentation, and they are, okay, that worked.
Yeah.
They can be polished further.
Yeah,
And,
nice.
and as you have seen, the messages tend to be very verbose, so they absolutely don't read anything out of them, because work needs to be done to choose exactly what are the relevant messages that you want to show.
Yeah.
Even just to show that something is happening, it's not just the thing
Working,
hanging.
yeah.
And you want to progressively educate them. Yes, there are Git behind the scene, and this is what this is doing. But finding the right compromises, and so that, and if something is wrong that is well visible, this would take a bit of policy and internal civilization now.
Yeah, excellent. I think I understand now. And the hour is on. Any more questions from anybody? Then I'm going to stop recording.